Good evening, everybody. I'm Brent Warner. I'm the moderator for this panel of Ask a Scientist, Space and Rockets. And I hope you guys have some questions. You'll notice that at the bottom of the screen, there is a Q&A little icon. Please use that to ask questions, and we'll try to get to as many of them as we can. And there's also a chat icon, and that you can use to talk amongst yourselves. And after the panel is over, there is Discord, where you can go on and talk about this stuff or anything you want to your heart's desire. We have some excellent panelists here. I am going to introduce them in reverse alphabetical order, and if you want to suppose that maybe I have alphabet issues, well, you can suppose whatever you want to. Valerie, would you introduce yourself, please?
Hi, my name is Valerie Mikles. I have a degree in astronomy. I was a black hole hunter for many years, and now I work on weather satellites for NOAA, and I help with the instruments and the algorithms and making sure that you get your weather forecasts.
That's very good. I go to weather.gov all the time. Inge Heyer, would you please introduce yourself?
Hi, I'm Inge Heyer. I am a professor for physics and astronomy at Loyola University, Maryland in Baltimore. Part of my career was working for the Hubble Space Telescope for 14 years. And now I enjoy teaching students various subjects, not just physics and astronomy. I also teach integrated science for elementary ed majors.
Okay, Pamela Gay.
Hi, I'm Dr. Pamela Gay. I am a senior scientist at the Planetary Science Institute, where I'm director of the CosmoQuest project, which does citizen science and engages a large community of people in learning and doing science through a myriad of different podcasts and other online events. When I'm not on the internet, I am writing scientific software and helping to explore other worlds, including our, OSIRIS-REx mission to Bennu.
Okay, and Ken Carpenter?
I'm Dr. Ken Carpenter. I'm an astrophysicist at NASA Goddard Space Flight Center. I work on cool evolved stars, trying to understand their outer atmospheric structure and winds and the mass loss that comes off of them. I'm the operations project scientist for Hubble Space Telescope and the ground system project scientist for what used to be the W1 telescope, but is now the Nancy Grace Roman Space Telescope.
Yes, indeed. We were lucky enough to have a talk by Nancy Grace Roman at Goddard a few years ago, where Ken and I both work. I work as a thermal engineer. We already have some questions. Let's take one here. What would a realistic design for a rotating space station look like? How would its construction process compare to the recent space stations? And are there any actual serious plans to do one in the foreseeable future? And what about intrasolar system craft with rotation capability to simulate gravity? I guess he's talking about that really cool looking spaceship in The Martian. Who wants to take that one?
I can start, and then if you guys want to add some stuff in my mind, the model for this has always been what was shown in 2001, A Space Odyssey, where you have a large ring of material, a large ring space station that's rotating around to produce artificial or centrifugal forces that mimic gravity as it pushes you against the outer layers of the station. And similarly, the Discovery spaceship in that movie, if you've seen it, has a big sphere at the front of it that's the crew quarters, but the center part of that, the equator as it were, actually moves around and again creates a centrifugal force that mimics gravity as you travel between planets. I don't know that, and maybe Pamela, you may be able to, you may know more recently, but I'm not aware of any real serious plans to do something like this in the near term, at least. I think in terms of construction, we would construct it in a similar fashion that we've done piece by piece with ISS, but you know, it would have to be bigger and involve a lot more effort and cost, I think, than ISS itself.
Yeah, I don't know the calculation on the size it would have to be to create a discernible gravitational pull, but it would have to have a very large radius, wouldn't it?
Well, it's a double issue. So you can have something quite small that allows you to experience Earth-like gravity on the outer surface of it. We've all experienced this with the carnival rides that spin you and lift your feet from the ground. But the issue is that the gravity just at the end of your arm is significantly different, and it's not actual gravity. The acceleration experienced by your hand at the distance of your arm is significantly distance different. In order to be able to have an experience where the entirety of your standing body can be if affected in similar ways, you need a giant ring. There's been occasional discussions about, well, you could do it practically using the Bigelow inflatable habitats and just create a giant group of them, but you can't do that in low Earth orbit, because then you run into the problem that the orbital speed you need for the two different extreme ends of this system are going to be very different. So we're not yet to the point that we're putting humans in high altitude orbits above the Earth. So we're not in a position that we can even consider building something like this. Now, this could change in the next several years as so many different companies work toward the Artemis project. Whether or not it succeeds, we're going to have the hardware developed to get us out into cislunar orbit. And out there, it may be more sensible to start building a larger space station.
Yeah, and that comes to a practical, like, just rocket advancement in a rocket or launch technology, and just advancement and commitment in our ability to get to and from, because even with the space station, one of our biggest things is making sure the astronauts have an escape, a sure and confident escape. And they're in low orbit. So you take somebody and you put them even further away, your first thing is, how do we preserve their lives?
Yeah.
I take it we have no immediate plans to build that thing, despite how interesting it would be and how much fun to see that thing go by overhead. But I would think it would be very difficult to build and take different techniques than what we use for the current space station, because it's rotating and you build it all complete and then spin it up. Or do you start small and then start adding things as it's spinning around? I'm glad I wouldn't be in charge of trying to make that work.
Yeah, that's an engineering challenge.
Well, I don't want to say I know, but I'm
it.
almost certain that somebody somewhere in their spare time is making these calculations and figuring it out. So if ever the president or someone in the government says, hey, we'll put money towards this, they'll say, I have a proposal ready.
And folks have figured out. Folks have figured out how to do it with the Bigelow inflatables, because they're small, they're tiny, they're easy to attach. We just don't have the tech to get them where they need to go.
And that's the thing, like, engineers are always thinking about these, but they don't have the funding to actually think practically and plan and build.
Yes, money makes the world go round. The Bigelow inflatables, for those who haven't read about them, are inflatable space station modules. So you send them up, they're small, they're compact, they get up into orbit and you inflate them and they grow up to be the big size. They were even mentioned in the old Collier's space project back in the 50s. We've got another question here. This should be quick. What is specific impulse and how is it calculated?
Okay,
not it.
Don't teach
What it?
that.
I know a little bit about it. It's a measure.
Oh, here we go.
Do you want me to Google it or something?
Of how much propulsion you can get per pound or kilogram or whatever you measure it in of fuel. And not my bailiwick, so I recognize it when I see it, and I recognize that the higher the number is, the more oomph you're going to get out of your fuel. But I've never had to calculate. Has anybody on the panel had to calculate that?
I haven't had to, but I've seen it done, because for the JPSS satellite, we know we're going to have to move it about a quarter orbit when we launch the new one, so that we can get the two satellites in opposition to each other. And so there's a lot of fuel calculations, a lot of impulse calculations to make sure that you raise and you lower it without killing it and burning up all your fuel. So I've seen it done. There might even be a simulation in my talk tomorrow.
Okay, what time is your talk tomorrow so that people will know?
5 o'clock Sunday.
Okay. Let's see, what else might we want to?
Well, I think one question here was about the SpaceX launch. We should
Yes.
address
Okay,
that maybe?
let's address that. Could you talk about the SpaceX manned launch and how it might differ from previous manned missions? Are there things to watch for or risks that might be new or different? And I will mention that May 27th is the target date for that launch. But of course, as we know, launches are often delayed. But
So-
let's hope it gets off on time and we can all watch it online. So who knows enough about it to comment?
So currently we are looking at only about a 30% go for weather. As of yesterday evening, I haven't checked the weather yet today. They are really, really hoping to be able to launch on the 27th because it's the 18 year, I believe, anniversary of having their Falcon rockets firing their engines. So that would just be a remarkable date for the company to be able to make it.
Yeah.
This particular technology is novel in a whole lot of ways, from the spacesuits down to every element of the launch vehicle. Instead of having the escape retro rockets attached above the crew capsule, they're integrated directly in. Instead of having separate solar panels, the capsule is wrapped in a solar array. We are still waiting to learn what the space toilet situation is. I haven't been able to find that, nor has anyone on my team found it published yet. The Soyuz has a space toilet that gets burned up every single time. So there's a whole lot of many, many expensive toilets that have been burned up. But it is, I return to having humans in space, and it's a new era. What I'm particularly appreciating is this is the crew capsule, and a lot of effort is being put into saying this is humanity's return to space. Let's no longer say manned space flight. This flight does have 2 men who are veterans of the Corps, but Artemis is already saying that the first women to set foot on the moon are going to be the next humans to set foot on the moon.
Very good.
We have another question here about the inflatable modules. How do the inflatable modules resist micrometeorites and other debris? Does anyone on the panel know enough about these to come up with a good answer?
So they have multiple layers of material on the outside. There's currently one actually attached to the International Space Station, or at least there was in December. It may have come down since then. That's being used for a long-term test of how well do they withstand the rigors of space. But by having multiple outer layers, it's considered to be just as safe as any other part of the International Space Station, which after all just has an insulated aluminum outer shell. So this is layer upon layer of strong, flexible materials that will stop the, well, incoming nature of a micrometeorite. Now, they do have to still periodically move the International Space Station to avoid larger debris, various things that have been dropped, shed, fallen off of spacecraft. But your average rock, it should be fine. And if you only get a small hole, they have ways to patch. It's okay.
Now, this is one question I threatened to ask the panelists before we got started. Who has a favorite form of launch into orbit that isn't currently in use, but you'd like to see in use? Anyone want to speak up on that?
I've always wanted to see the electromagnetic rails that we were promised back in the 50s, you know, the Fireball XL5 and the like, where they electromagnetically accelerated along rails, the spaceship, and then shot it up on a curve, and then the rockets would ignite after you've already been put into the air and given a head start, which allows you to reduce the amount of fuel that you have to carry on board, and, you know, makes the spacecraft lighter. at the
That
same
would-
time.
That would be a seriously cool ride. One of my favorites is that came from reading the Mars trilogy by Kim Stanley Robinson is the space elevator. That is something that I think would be really, really interesting and has definite promise. So
I think for that, we're waiting for a sufficiently strong monofilament to hold it all together.
yeah, again, it's a matter of developing the appropriate both technology as well as materials to make that happen. But I think that's doable within.
Also, the appropriate international agreements.
Wait, okay, that there you may have hit a snag, but yeah.
It's interesting that the Kim Stanley Robinson trilogy you're talking about, Red Mars, Green Mars, and Blue Mars,
Right.
they put up the space elevator on Mars, where
Right.
there were not a lot of problems with negotiating international agreements, and where, if, as I understand it, it doesn't have to be quite as strong a material to make one on Mars.
Right.
And they have giant equatorial mountains that decrease the height that you have to
Yeah.
accomplish your chord
Right.
across.
Arthur C. Clarke, when he wrote about one on Earth, put it in Sri Lanka, I think. I don't know if that's
Which he moved, so it was on the equator.
Yes.
You can do that if you're an author. Valerie, did you have a favorite launch system you would like to see?
Well, not one fictional, but I like the Pegasus where they launched the satellite from the back of the airplane. And I would like to be in the airplane to watch that go off, because you don't really get to watch those launches the way that you do things that go off the ground. But just in general, I'd like to see what we could do with nuclear power. Like when we get it safe enough that we feel confident we can launch it without, killing the world.
Mm-hmm.
So, because I think we'll go much further, much faster, much cleaner, and a little less smoke.
Okay, let's try another question from one of our watchers. How long could artificial satellites in far geosynchronous or farther Earth orbit last? What would the end of a satellite in a graveyard orbit look like? Who wants to take that one?
Well, the oldest operational satellite we have was launched in the 70s, and it's still doing communication. It really depends on the satellite. Once it's in geosynchronous orbit, it's pretty stable. And the only thing that's going to get in its way is if it gets knocked by other objects that hit it and kill it. So we don't tend to deorbit things that we put that far away from us. We tend to deorbit the lower ones because those can cause more damage to us.
Yeah,
But,
so it's low Earth orbit, as you're referring to, is where you get the satellites falling out of orbit due to friction with the atmosphere. And actually, in recent decades, the solar cycles have been very low, so the atmosphere hasn't heated up and expanded as much as it typically does in older solar cycles. So there hasn't been as much drag in low Earth orbit as you would expect. So a lot of observatories like Hubble Space Telescope are actually, without reboost, staying up far longer than we would have expected because of this reduction in solar activity. So Hubble is, looks like it's going to make it not only to the next solar cycle, probably through the next solar max and into the 2030s or something, which when we first launched it, we were worried every 11 years whether we were coming down, and now it just keeps going with no help. It's great.
But I know for all the newer NOAA satellites, they have to have in their plan a fuel budget to deorbit the low Earth orbit ones, because they just have decided it's a safety issue and they don't want to, we have so much space debris, so much space junk already. So if you get to a point where you're going to lose control of the satellite, it's we want to keep it up until it dies. No, you have to bring it down. So.
Even Hubble is subject to the same rules. So when we start getting down low enough to lose control, we're either going to have to bring it in a controlled fashion into the Pacific or boost it really high to, geosynchronous or something higher.
Right.
So that our kids worry about it.
There's a third option now. There was recently the successful nabbing of a Northrop Grumman satellite by essentially a robotic fuel pack that was able to bring it back into normal operation. So we're now starting to explore ways to either jumpstart spacecraft by plugging into them with these little carrier robots, essentially, or to just, well, carry them around as needed when they run out of fuel.
Yeah, there is a project ongoing at Goddard right now to refuel a weather satellite, Landsat, I think, I forget which one. And the idea is just to go up, unscrew the fuel cap after cutting a bunch of connecting wires and whatever, and putting fuel into it and hopefully sealing it back up and extending the life of it.
What's the current name of the program?
OSAM-1.
Okay, that program is now named OSAM-1, and it's Landsat 7 that is the target to be refueled. Now, for a little bit of a change here, we've got a question: are there any new and upcoming solutions to provide better radiation shielding for the human occupants?
I don't work on the human side.
Sorry.
Okay.
Not that we've been able to find in doing news on this.
Okay, that is...
Because, I mean, the space station has a sort of a safe room, is that right?
They throw people in the Soyuz.
Oh, okay. Attached
Okay.
safe room.
We have a comment on the inflatables. Someone writes in that the beam module still attached to the International Space Station has worked out better than expected, which of course is good news. Let's see, what else can we get into? Oh, we were starting to talk about, is there a serious plan to address space junk? And Pamela had something to say about refueling, as did Ken, and Valerie has also commented on that. Do we have any serious other plans? Although I will mention, I know that some people have talked about using electromagnetic tethers. You drop a tether out of the spacecraft and it's electrically conductive, and as it passes through Earth's magnetic field, that generates a voltage, and if there's enough plasma around, you can get a complete circuit, and as you are doing work, that work has to come from somewhere, and it comes from the energy of the orbiting spacecraft, which gradually diminishes until it re-enters and burns up. But any members of the panel know of any other proposed solutions?
I remember seeing a talk at Farpoint this year about orbital space debris, and this problem has been known for many years, and apparently all of the money that we've put towards it so far has resulted in a quarterly newsletter where we track the orbital junk. And in ideas for practical solutions, but no actual money to engage in it, because a lot of the stuff out there is not whole satellites that we can refuel. There's just so much that are just like tiny things and paint chips and pieces of satellites or screws that fell off somewhere. So it would take a concentrated governmental investment, because I don't think a space junk collector is sexy enough for the private sector.
And we should emphasize that even those tiny little pieces can be dangerous. Even a screw or a paint chip traveling at thousands of miles an hour is not something you would want to have run into you.
Mm-hmm.
Yes,
So,
definitely.
Definitely would like to see somebody work on it though, because at Hubble we get alerts every once in a while that there's incoming space debris, and we unfortunately don't have rockets or attitude jets on Hubble, so we can't move out of the way. The only thing we can do is tilt the telescope to put the back end where most of the mass is toward the incoming radiant, and hope that if it hits anything, it's not doesn't hit anything more sensitive, or it gets stopped by the mirror at the back end. But
The newsletter is pretty cool though. So if you're bored, you can check it out. Also, the United Nations Office of Outer Space Affairs has a catalog for satellites and space things that they track. They have about 10,000 objects that they are tracking of various sizes. Probably like 2,000 or so. Those are satellites, but.
Right, isn't NORAD tracking anything bigger than about yay?
Yeah, so, different people are doing it, but the United Nations everybody in the
Right.
world can.
Right.
Also, who doesn't want to visit the Office of Outer Space Affairs? It just sounds
It's
cool.
in Vienna. It's a gorgeous area. And there are also large offices of human beings sitting at computers, refining trajectories, and literally getting on the phone to say to companies, hey, one of your satellites is about to get hit. You need to move that sucker. We have one of the friends of CosmoQuest who is one of these humans. He's had unfortunate situations of just can't get anyone on the other end to answer the phone. It's always worked out for the best. They've always gotten a hold of people when they needed to, but there are human beings out there tracking this and using the good old-fashioned telephone to make sure everyone's in the know.
Yeah, I mean,
Yeah.
we spend billions of dollars on these satellites. We want to protect them.
Here's an interesting question. If you were on one of these longer missions with no practical resupply opportunities, what kinds of unusual things would you want in your toolbox and spare parts cache that would be practical to bring into space to deal with unforeseen problems?
Is it flippant to say duct tape and and the wrench?
And the WD-40.
That too. Okay.
Well, I mean, I understand the astronauts who went to this to the Hubble missions had a box of extra stuff, and I don't know if one of them was duct tape or not, because I remember for one of the servicing missions, they discovered that the outer layer, the protective layer, had to become brittle. It was actually flaking off, and they had to make a temporary space blanket to put on top of that with whatever spare bits they had lying around. And so these were, I think, that involved some thermal blankets and I forget what else, some wire.
Yeah, something to stretch it out and allow it to attach.
And
Yes, something like that. So basically the people on the ground knew exactly what they had to do and what parts they had, and then they figured it out, and then they faxed up some schematics, and then they made it in the shuttle.
And the current plan is to start outfitting more and more spacecraft with 3D printers. If you have a 3D printer and enough diverse goo modules, I'm forgetting the actual word at the moment, the extruder materials, you can make anything. And they were testing a 3D printer up on the International Space Station. They made one wrench. And this allows you, as we've seen with the COVID disaster, to essentially replace almost anything if you can just get the design plans. So we're looking for a future where it's our 3D printers and Glowforge cutters who are going to be innovating how we, live in the moment when we have very limited resources.
I'd be interested to see, have they tried the thermal sheets and like fabrics with 3D printers, or is that too soft?
And these are the things where we're still figuring out exactly how to do the thin films and stuff like that. So at a certain point, you're going to need to have certain things with you, the base materials. And this is where it's a combination of what are the things you extrude and build up, and what are the things that you take in bulk and cut down. So the combination of a laser cutter like a Glowforge and a 3D printer allows you to go in both directions with the base materials you take with you.
I use my level all the time. I guess that you don't really need that when there's no gravity, but you know.
You can use one of those angle things. That would be super useful.
Yeah.
Okay, any other tools you would like to take along? Okay, one of my favorite tools is a gimlet, but I don't think you take that along, too much risk of poking a hole in the side of your spaceship. Here's another item I have actually heard about from my friends who are amateur astronomers. I've heard concerns about commercial space flights and private satellites getting in the way of astronomers being able to see from Earth-based observatories. Is this a legitimate concern? And this is talking about the constellations that will have hundreds or thousands of satellites.
That was a big topic at the last live AAS we had. Pamela, you were there, weren't you?
Yes, and I've written some articles on it since.
Yes.
So what we're looking at is massive surveys that have been developed very specifically to allow us to survey the entire night sky. The Vera Rubin's Large Synoptic Survey Telescope, for instance, are not going to be able to accomplish their mission because it's estimated that perhaps 70% of the images will have one or more satellites in them, depending on how the constellations end up fully developing. This isn't a problem just with Starlink. There are multiple nations developing many thousand satellite constellations, because ideally, in order to have good low-cost internet for every point in the world, you want to have at least 5 satellites overhead at any given moment so that you can constantly be handing off between different satellites. This is going to be an issue on 2 different levels. The first level is, as they are currently being built, they saturate the detectors in your average telescope camera. It's sort of like pointing your cell phone camera at a laser. Those pixels aren't going to be useful for seeing anything for a little bit. Now, even if they do dark coat these satellites so that they're no longer blasting our detectors past their saturation point, they're still going to be obscuring objects in the sky, and they will never be so dark that we won't see them with our telescopes. So as they fly by, they're going to be cutting off our ability to see anything in the pixels they pass over in those images. This is going to have a significant cost to the time it takes to accomplish our science. You have to take image after image after image, hoping you can get enough images without satellites in them to actually study your object. Now, at the same time, this is a humanitarian question of, there's many places in the world where there's no feasible way to build infrastructure to give these people access to high-speed internet. And as we're all currently trapped in our homes, think of the kids who live someplace where they can't use Zoom because they're farm kids, and that's not even an option over the dial-up they're still using. It costs too much money to run the lines to get internet to these places. So this is how we break down the digital divide. So it becomes a question of, do we break down the digital divide by having a gazillion satellites in the sky, or do we not do that so that astronomy can continue to advance at a breakneck pace? And unfortunately, there is no neutral ground. We either wreck the sky, and even the Hubble Space Telescope has had one of these annoying satellites go through its field of view. It wasn't a Starlink satellite. It's had an annoying satellite go through its field of view. So sticking telescopes in space isn't necessarily the option. We either ruin the sky for astronomy until we get better technology and we can start doing this kind of communications from a geosynchronous orbit, or we continue to maintain a digital divide. And I hate the fact that morally the better thing to do is to wreck the sky for astronomy, and allow people in remote places, whether they be islands or farm country or just rural woodlands, to, well, finally join the online economy.
Well, beyond just internet as well, just from the weather perspective, from the NOAA perspective, even they're looking towards the smaller sats and the CubeSats to get better global coverage and to lower the latency. Because right now you have to wait until, like if you have your polar orbiting satellite, you have to wait until it gets in view of one of the poles to get your data down, or you have to have your own station set up to fly over. And having all of the, like having the extra internet allows you to reduce that latency. You can send fire rescue faster. You can send this or that faster. So there's also, you know, so it's not just internet. There's plans to leverage this to get better weather prediction so that, you know, you can maybe save more lives or do satellite assisted rescue. And so, it's still on the humanitarian side, but it's beyond just getting internet to rural areas.
Yeah, and it's causing some rather unfortunate debates where you hear the exact same people saying expletive, expletive, expletive. We need to build this telescope on this land that people call their sacred space because my science matters more than their culture. And then those exact same people, when faced with these constellations of satellites, say, you can't do this because you're ruining the sky for generations of people. You're ruining my culture. You can't launch these telescopes. And given the choice of doing science or doing the right thing for humanity, there are people who will always argue science above humanity, and it's kind of hard on the soul.
There are people who will always argue their interest over other people's interest, regardless of where the rights and wrongs are.
Yeah.
That seems to be how human beings are wired.
Well, in some way, we just need to be vocal about these interests so that we can understand what the give and take is. It's not that I would disagree with somebody on the other side. It's that if I don't express my side and they don't express their side, then we don't actually understand the full consequences of the choice, and we can't make a reasonable choice.
Yeah.
So,
One thing that does not help observatories on the ground or even in low Earth orbit, but the next generation of large space telescopes are actually going to be put further out in space, a couple million kilometers at the Lagrange 2.2 or in particular. And those will be far above these massive constellations or anything that you would expect in the near term. But that's only going to be, a handful of the largest and most expensive observatories. You can't put the ground facilities up there, and even the average Earth orbiting observatory is not going to go that far out. It's just the big ones that need to be away from contamination and the brightness of the Earth.
Yeah.
Well,
But at least it's something. So James Webb and the Nancy Roman telescope won't be bothered by this.
Speaking of James Webb, what's the latest launch date?
Unknown due to COVID. Prior to COVID, they were pushing for March 2021. It is looking like no one has an estimate, nor are they going to articulate one at this moment. The current push is to launch Perseverance, come hell or high water, on time. God, expletive it.
So that would be July 21, right?
Yes.
For Perseverance? Yeah, okay.
No. It's going up this year.
Yeah, I mean, sorry. Yeah, July 20, and then for a landing at some point in 21.
Yes.
Okay.
Yeah, so all the current push is to get Perseverance off the ground.
Okay.
By the way, the Nancy Roman Space Telescope that Ken Carpenter mentioned is the renamed W1 in honor of Nancy Grace Roman, who was sometimes called the mother of Hubble because of her role in shepherding the Hubble Space Telescope through its many difficulties. But she is also the grandmother of Hubble because she was behind the early astronomy satellites that proved that you could do astronomy in space, so that when people were pushing the Hubble Space Telescope, they could refer to these previous satellites like the Orbiting Astronomical Observatory Series, OAOs, which proved that you could do astronomy in space. And so the Hubble was just a bigger and better version of something that had already worked very well.
Yeah, and it's a bit awkward to always say that she's the mother of this, the grandmother of this. She was NASA's first chief astronomer. And she was the human being who fought tooth and nail to make NASA a entity that had a major science focus. And she was a PhD scientist in a day where that was rare for a woman. And she was with NASA after 6 months after its foundations, and was there to help define the organization as one of the few places that has a history of having women since before anyone else had women doing science.
Nancy actually visited NASA Goddard a couple of years ago, 2017, I think it was, came out to see the Hubble Operations Center and the other places at NASA. And it was very touching to see. One of the events that we did during that visit was to gather a number of the women working currently in the Hubble Operations Center. And they posed with her in front of the Hubble model there.
Wow.
And it was just, you look at this and think, she's the one that made that happen. She broke the prohibitions against that, and in large part because of her, that room looks like it does now, with all of these women in it, in addition to the gray-haired guys.
You can get a Lego version of her in the Women of NASA Lego set.
Got it.
Yes, indeed. I think a lot of us do. Now, okay, let's move on to something else.
Can I propose something? There's a question here about science and science fiction. What science and science fiction annoys you the most?
Okay, we can go after that. Since you brought it up.
For me, it's actually not what particular science. Obviously, in science fiction, what matters are the stories. And if you invent science or try to get around some science, I don't have a huge problem with that. What it has to be is consistent. So I get really annoyed if they postulate something in the beginning and then halfway through change their minds that, no, it works this way, right? And the other thing is if they are just lazy. So I wrote a somewhat scathing letter to the Star Trek Next Generation people at some point, because for the story, it made absolutely no difference what the science fact was in this particular case. They got it wrong because they didn't do the research. You just had to look it up. It wasn't a big deal. That annoys me to no end. Now, if they invent something that we can't really explain, like the transporter, for example, I'm cool with that. But stay consistent and don't get anything wrong just because you don't want to look it up.
One of my pet peeves is when you see a piece of art and they have the landscape and the mountain and the planet in the background that's as big as about a quarter of the horizon, because I've done that math and you're dead. And I understand from an artistic perspective, if you're looking at still frame or a cover, sure, I'll accept it. But if we're in a film setting and, you have people in the foreground, I want the background to at least have enough realism to say the planet's that big in the sky. You use your art and then use your film to bring realism to it. So it's just like a little thing, but I can appreciate that it's art and it doesn't have to be scientifically accurate.
Yeah. Or having a moon up there, very nice and romantic, but it's lit from the wrong side.
Or it's the wrong phase for the time of day.
Yep.
So those I'm willing to kind of give them credit for just having a moment.
Yeah.
I think all of us at one point in our lives have screwed that up just in a moment of oops. It's the quite purposeful things that get repeated, like the giant moons. Yeah, there you're totally right. But I'll give them the phase here and then because we've all gave that.
Yeah.
A couple of years ago, I was traveling, and in the hotel they had a lovely mural of this was in Nashville, the Nashville skyline with a big full moon in the sky. And if you looked at it, you realized that the moon was upside down for the way it's seen from the northern hemisphere. My favorite way of checking that is actually not the man in the moon, but the lady in the moon, if you know that image. There are, of course, a lot of pictures that people see in the moon, including the rabbit and other things that I'm not aware of. Ken, do you have any favorite pet peeves?
Well, there was one relatively recent movie, Gravity, that kind of tore me in different directions. There were pieces of it that were really cool, like when she shoots the fire extinguisher to put out the flight, she goes flying back in the other direction, and perfect illustration of one of Newton's laws, yay. But then they go flitting back and forth through all these orbits that it's completely impossible to get through, from the Hubble orbit to the space station orbit, and then they make up a Chinese station or in another orbit they couldn't possibly get to. So I hate it when they completely ignore orbital dynamics. I'm fine if they go with the transporter and just sidestep it. That's great, but don't try to stay in the real world and mess it up so badly.
Have you ever caught the units they use on Star Trek? They are forever dropping out of warp 700 meters off the bow of another ship going a bazillion kilometers per second. And it's like, no, you're not actually doing that, or you would have hit them. Sorry.
Precision navigation.
Okay, I suppose we all remember how the Heisenberg compensators work on transporters. The classic answer is they work very well, thank you.
I think that's Michael Kuda's response, actually. It's very nicely done.
Yeah.
Okay.
They know there's a problem. It's like, yeah, we know it doesn't work, but just pretend.
Yeah, one question we got, I think, ahead of time is how many planets can you stuff in a solar system?
Do they have to
That's-
orbit, or is it just a matter of, packing them in?
Well, I mean,
Well,
they should orbit.
If you
I think
wanted
the idea
to.
is stably, how many can you pack in?
Yeah. So, I mean, I think there is no particular answer you can give it because it depends on a whole bunch of factors.
Including your definition of planet.
Okay, fair enough. That too. But no, I mean, when a solar system forms, you initially have many more bodies forming that will eventually end up in a stable orbit. I mean, you have bodies merging, you have some being tossed out through gravitational sling. So you can't really say exactly how much. If we look at all the other solar systems we found so far, what is the count up to? 4,000 or some such, right? None of them look like ours. None of them look like each other. We simply don't have enough information yet.
You could, if you wanted to, take all of the planets and dwarf planets in our solar system and fit them between the surface of the Earth and the surface of the Moon.
And
Now,
then they would crash, but it would be really cool for a minute.
It would be so cool for a moment.
move on. We are getting very close to the end of the panel. 2 minutes, our text says. Let's see if anybody has any last comments, and we will go in reverse order that we started. Ken, do you have any last comments?
No, I do see there's a question in the Q&A about spacesuits and how hard they are to get in, whatever. I think there was an allusion by Pamela earlier that the new suits that SpaceX is working on are looking quite a bit more sophisticated and easy to move around with, and presumably to get in and out of, although I don't actually know that.
Pamela, any last comments?
The universe is vast. To understand it, it's going to take all of us. And there are myriad projects out there that you can volunteer for. If you want to find out more about what I do and how you can get involved, check us out at cosmoquest.org. And we do a daily news show on twitch.tv/CosmoQuestX.
CosmoQuest. Okay, remember that. Inge, last comments?
Yeah, let's just keep the conversation going, really. And try also to talk to people who may be not as science-oriented or science-interested as you are. I mean, obviously, all the people who are here participating have a great interest in all of this. We need more people to get interested in it and to try to understand some of it. We currently have a lack of science understanding in the general public, and if we can contribute to better science education simply by talking to our neighbors, talking to our family, I think that is a good effort.
Okay, Valerie, comments?
Just that keep asking questions. If you are on Twitter, there are a lot of things. I know at NOAA Satellites posts a lot of stories, just some of it's random pictures, some of it's things. NASA has a science visualization studio, SVS, and you can get all sorts of visualizations for things, and you can ask them questions as well, because they're always looking for what their audience wants to know. So definitely find these NASA and NOAA science sources on Twitter and just follow their feeds and see what they have to say.
Like the Scientific Visualization Studio at Goddard, you can look that up. They use some of the same software as Pixar, and at least one person has worked both at the Visualization Studio and at Pixar. Great stuff there at the Scientific Visualization Studios. And there is a Discord site for Balticon, and everybody who wants to discuss this sort of thing should head over to Discord. Thanks to all of our great panelists, and thanks to all of the audience members. and hope to see you next year at Balticon.
See you next year.
Thank
Bye.
you so much for
Bye-bye.
asking questions.
Bye.